Listen, you can tell me whatever you want, but I know you're having wet dreams about making this like glowing orb going on a wave kind of thing, and why shouldn't you? You know, it's a classic geometry nodes project that I don't know if anybody's ever explained before, so let me be the one to explain how to make this like procedural setup that makes the waves and the whatever. I mean, let me just show you. I mean, here's basically what we're going to be making. It animates, and it animates very slowly, but you can get a cool view of it. You can change the number of orbs, etc. Let's just get into it and then render it. So with Blender open, I'm going to be using 3.0 alpha. It doesn't really matter what you use as long as it has geometry nodes. We're going to do just that. We're going to go into geometry nodes. So geometry nodes is a workspace made for us that has the spreadsheet, it has the thing, and I'm going to treat it like you haven't used geometry nodes much before. I'm sorry, Billy. I know you're in the 3rd grade, but we're going back to 2nd grade. With the cube selected, what we are going to do is we are going to make a geometry nodes network, which adds a modifier. I'm going to delete this so that we don't have the cube and instead replace it with a grid, which is a fancy word for plan. And why are we adding in a plane for this glowing orb thing? Well, if you can imagine, we're just going to make a big plane that distorts like a wave, so now we have a bendy plane, and then if we just put spheres on it that follow certain rules, we've made the effect. So with this plane, I'm just going to make it a bit bigger. By a bit, I mean a lot, so 5 by 5 meters, and I'm going to take the vertices and increase them. And you can see in wireframe, we actually see that information. In Solid, it looks the same, but in wireframe, you can see all these points. So I'm going to do something like 50 by 50. We can change this later, and you can see that now we have position data of every single vertex, and there are 2,500 of them, 50 times 50. Okay? First thing we need to do is we need to distort this thing to behave like a wave, and there's no displace modifier here. We got to use our brains. So what we need to do is somehow bring in a noise texture. To do this, I'm just going to use the attribute sample texture. What does this do? It samples a texture. We're going to use a noise texture, and it writes it into an attribute, which is a thing that we can modify. I'm going to make a new texture. What am I going to call it? I'm going to call it noise. Why? Because it's going to be noisy. For this noise texture, we can pick whatever we want. I would recommend clouds because this is the simplest one. So basically you can think of this as this cloud texture is being projected onto the plane. But how is it being projected? Well, with the mapping, we choose either UV map, so you could just use the UV map, or the position. It doesn't really matter too much, but I would recommend position just for this case, since we're going to be modifying this attribute a bunch. And we're going to write this result to a new variable or a new attribute we can call noise. So what has happened here? We've taken the position of every single point, mapped it onto this texture so we know what value it has, and written it into this noise attribute, which you can see has a bunch of random numbers in this X, Y, and Z. And what we want to do with this is somehow displace our plane on the Z axis, up and down with that information. Well, first of all, you can see we have X, Y, and Z data here. It's actually 4-dimensional, but never mind that. So what we need to do is make it suppressed on the X and Y. To do this, I'm going to use attribute vector math, not a attribute math, but vector math that has X, Y, and Z components, and we're going to modify it. So I'm going to take my noise, and I'm going to modify it by multiplying it by a vector. Let's use a 0, 0, 1. What this is going to do is it's going to take our vector, or attribute vector, really. Our noise, it's going to take the X channel multiplied by 0, so it's gone. Same for Y, and then Z is now going up and down because we multiplied it by 1, nothing changed, and we're going to write it to noise. So in other words, if you look at this noise here, it has X, Y, Z, and now it just has Z information. We take this, and now we just add it to our position, and you will see it does exactly what we want. So I'm just going to do vector math for attribute. We're going to use addition, and what I want to do is I want to take the position and add it to noise and make that the position. So again, we've modified the noise so it's only on the Z-axis, and now I'm adding position and noise and rewriting it to the position, so it's being updated. And you can see now we have something that looks like this. How do we make it look better? Well, we just changed what the noise looked like to begin with. So I'm just going to make this noise bigger and maybe a little less detailed. And you can see that's already looking pretty good. The more geometry we add in, the smoother this is going to look. But you can see it's looking pretty good. Now, all we have to do is for each point that's now been displaced up and down, etc., we just need to put a sphere on there. Well, we just have a series of points. Again, yes, they're displaced, but just a series of points. So I'm just going to use the point distribute node, which is going to take all these points and distribute, Nope. Point instance. It's going to take all these points and instance. It's going to copy a certain mesh that we pick. So I'm just going to pick UV sphere. We can make it lower resolution. Doesn't need to be high res, especially when we make 2,500 copies of it. And for our geometry nodes object, just instance the sphere. And you can see now we have this kind of like anime blobby looking thing. So let's bring down the scale of these spheres by taking each point that, again, we're instancing on and scaling it down by the same number of float. So we just make that nice and small. And we can look at this from the top view to see if these are touching. Beautiful. So now we have the basic system of points going on a distorted plane. But I click play, it doesn't animate. How do we animate it? Well, to animate it, we essentially need to animate our noise texture, which we cannot do. There's not an option for that. So instead, let's modify how it's being mapped onto it. So if we change the coordinate system, then it will look like the noise is moving. Well, we're using position as a coordinate system, so let's just modify the position. I'm going to use some vector math, set it to addition. I'm going to modify position and rewrite it to a new coordinate system. We can just call it chords or whatever. And this is what we're going to use. And you can see what we have now is we've taken the position, we're adding in some vector and rewriting that to the coordinate system, which means it's going to be like position, but now we can offset it on the X channel, the Y channel, so this is only Y motion, or the Z channel. And now we could just animate this. So for the X channel, I'm just going to type in a driver. Hash frame gives us the frame number divided by 60, let's say. So it's going to every frame update this by a 60th of a unit. So you can see it's moving to the left, or is it to the right? No, to the left. We can also do a bit of that on the Y. So hash frame divided by, let's say, a different number, 45. So it's going at a different speed. So they look a bit independent of each other. And then finally, a bit of animation on the Z by 80 or something, just so that it feels like it's more dynamic and changing. If you make this number small, it will look very up and downy. So I've invented a new word. I'd recommend making it a big number. But you can see this is kind of like the essence of the effect. So now what we need to do is make it look interesting and render it in an interesting way. By the way, let me save this. I'm going to call it plane with points. That's going to be available on Patreon. So you could just download that if you are a patron, the blend file. But whatever, let's keep constructing it. Obviously, we want to make it glow. We'll get to it. But another thing I want to add just for this geometry is all these spheres are basically going up and down. That's what we've designed. But I would like a way for their size to change, where the higher it is, maybe the bigger it is, and if it's low and not glowing, maybe it should be shrunken, so there's a bit more dynamicness to it. In other words, we want to animate the scale, but not by the same number, by a attribute. What attribute am I going to use? Good question. I'm thinking about maybe taking the position, the Z position, the higher it is, the bigger that it is, and using that as the scale. So let's see what we can do with that. We want to separate by X, Y, Z, Y, because we're going to, X, Y, Z, Y. Why do we want to do that? Well, because we want to take the position, right, which is now going up and down. That's where we are in this phase. And we want to separate it so that I only care about the Z channel. So I'm going to call this height or something like that. So again, we're only looking at the Z channel, and we want to map that to the size. And you can see it looks, now this is an interesting effect. This is how you do some kind of animated cloud thing. Maybe I will come back to that. But you can see the higher up it is, it seems like the bigger it is, and that's what's happening. We just need to somehow scale it so it's not as insane. So now let's do an attribute math, not a vector math, but an attribute math, because it's no longer X, Y, Z, it's just one channel. And what I'm going to do is I'm going to take the height, I'm going to multiply it, in other words, update it by some number. So when it's 1, we had what we had before, and as it gets smaller, it will look like it makes more and more sense. So what we have now is the more high up it is, the bigger it is, and you can see these spheres that are low, as you can see right here, these low spheres are very tiny. And we can change the scaling factor. We don't want it to be too big, or these top spheres are going to intersect, so maybe we just find 0.1 seems too big. Maybe 0.08 was correct. You want to pick one of the biggest numbers that would prevent intersection. So you can almost see this noise now. I mean, you can from the bird's eye view, just using this scale information, but that looks pretty cool. Now that we have this set up, let's render it and give it materials and all that. I think that'd be cool. So for materials, we are now opening up the shader editor. Goodbye, geometry nodes. We're familiar with the shader editor. We're going to call this glowing glowing material. And you can see when we're in Eevee and we're in rendered mode and all this, When we change the material, nothing happens. And I know, Billy, you've heard me say it 1,000 times. By the way, if your name is Billy, comment below. But and I'm sorry for calling you out. But you can see this material, even though it's applied to this mesh, it's not updating. And that's just because of geometry nodes, whatever. You want to use a material assign node. So we want to take all of this, the plane, it's distorting, there's noise, whatever. And we've instanced the spheres. We want to take all of that, and then at the very end, we're going to assign it a material. And this is tedious, but it also gives us some new possibilities if you have multiple materials and you want to switch between them. But you can see now this is updating. However, if we want to somehow take the height of this and like map it to, we're going to struggle with that. So what we need to do is we need to change to cycles. And before we do that, let me just explain what I mean. So for example, if I wanted to take an attribute after we point instance, I believe. So we might need to do this again, I believe. So we're going to take the position and create a new variable, a new attribute. I'm just going to call this shading or something like that. We put this before the material assign. If we use an attribute node here and we use the same attribute, so I type in shading, which again is the Z component of position after it's going up and down, you're going to see that it doesn't really show anything, even though attributes should be shared between these systems. So you got to change to cycles. It might change in the future, but for now, cycles is the only one that's compatible. And you can see in cycles, we can actually see this information. It's a little hard to tell, but you can see how these higher spheres are whiter and these lower spheres are darker. It might be easier to see if I send this through a color ramp where one of these is black and the other one's red. Let's make one of these maybe not black, but blue. You can now see how both colors are here, both red and blue. You need to be in cycles for this information. Now, I know what you're thinking. Yes, you could technically use this information without an attribute, like we do have this geometry position node, and we could separate it by X, Y, Z, and that'd be faster. But for the sake of this tutorial, let's just use geometry nodes. So for the material here, I just want to make it dark. And by the way, I'm noticing that you can still see the faces here, which is not what I want. So I'm just going to use a attribute fill. Why? Because we want to fill in the shade smooth attribute to be smooth. So attribute fill at the very end, we're going to take the shade smooth attribute, which is already here, set it to 1. So that's going to make everything shade smooth. Everything's going to have a shade smooth of 1. We want to take this and now make a custom material. So like I said, we're going to make it black, and we want it to glow, let's say orange or red or whatever, but only in some areas. So again, we're going to use this shading factor as the emission strength. So the higher it is, the more it's glowing. And because we can't really see the fall off, I'm just going to use a color ramp to make it more obvious. So you can see the more we bring this to the right, you can almost see a cutoff here, right? Between what is and isn't glowing. And for the ones that are glowing, I want to make them brighter, maybe even twice as bright. So that's a trick you can use in the color ramp. So now, I mean, it does need to update, but now as this, plays, you can see whichever sphere happens to be up high, which is going to change all the time, that one's going to be glowing. And let's just set up our camera before getting into the nitty-gritty. So 150 meters, so like a very zoomed in camera. View, camera to view, just so we can like move this thing. So something like this. That looks pretty good. What do we want to do with this? Viewport display. I don't want to see the outside, and let's just remove this environment lighting. So this is what a frame would look like. We could render it, and let's see what that looks like. Okay. It looks good. We need to definitely add in some glowing and stuff like that because it's kind of looking dull right now. But you know what? Let's do that. No, let's not do that. First, let's make this more visually interesting is the point I was getting to. So instead of what I think all these demos are doing where they just have like the glow be orange or red or whatever, let's use multiple colors because we have this factor information. So color ramp, use the factor to the emission. But first, let me copy this orange so you could just hover over this Control-C, Control-V. So when I plug this in, nothing changes. What I want to do is have multiple colors. So like, for example, I could have blue. Whoops. I only want to modify this first one. I guess it was modifying the first one, but we just got to move this slider here. You can see with this color ramp, we can actually have multiple colors depending on the height. So again, this is just a gradient on the Z channel. And I think this adds some visual interest, but instead of like these colors, you want it to be more like, you know, yellow and orange. So we can have yellow be the bright colors because I feel like that looks cooler, and have a bit of a softer fall off, maybe even a B-spline. That's how you get it really soft. Although I don't really, maybe an ease. There we go. I like the look of that. I would recommend adding in multiple colors because it just makes it feel more vibrant and dynamic and all this. And now let's do a bit of compositing. So if we were to render this, you know, you pick a random frame, you hit render. It will look something like this as it finishes. And it just kind of looks boring. So let's spice this up a bit. So in the compositor, we're going to take this render layers and, you know, view it. But this is essentially what we get rendered out, and we want it to look cooler. So obviously the first thing to do is to make it glow. So I'm going to use a glare node. I would recommend fog glow. There's different kinds of glows. Bring down the threshold to something under 1. So you can see here's before, here's after. Let's increase the size of the glow. And also, instead of just like taking the image and processing it through this and just kind of getting what we get and not being able to control it, let's add in a bit of control. So if we take the mix and bring it to 1, you can see this is only outputting the glare. If it's a -1, just the original render. 0, it's going to mix them. So I'm just going to output the original glare. I'm going to mix these two together using addition because we're adding in light. And you can now see one's like overlaid on top of another. What I want to do now is, because we've mixed it this way, we can change the factor. So if it's 0, we get the original image. When it's 1, we get glowing, big deal. But the point of this is now you could set this to a bigger number, like 2, and you get twice the glow. And also because we've separated it, we can control the quality of this glow. So for example, here's the glow. We can blur it out by, let's say, 25, and that will give us a nice soft glow that is now being overlaid. It's going to look much cooler. So again, here's without blur, and here is with blur, and we can make that even more ridiculous. So we're kind of increasing the size of this glare almost. And you could get ridiculous with this. It kind of depends on what you want. But I think 50 is plenty, and maybe 1.6, just so we don't max out here. For the color management, I would recommend playing with the exposure. How bright do you want this to be? And also the gamma, kind of the intensity of this render almost. And I think that that's a good start. We can also add in a bit of lens distortion in terms of actual distortion, like how much is the lens curving, right? So you set that to like a small number. You set it to fit so we can actually, you know, we don't have these corners cut off. That's why we enable a fit. Maybe also add in a bit of dispersion. That's chromatic aberration that you see in the corners. For this one, I would recommend making it lower. So that's a couple things we can do. And then just to give this thing a bit more dynamic feel, I would also recommend adding in motion blur. So now when we re-render this, you're going to see some of the spheres have a tiny bit of motion blur. So you can almost tell this one that is going up is a bit blurred. So that's one thing we could do. I would recommend taking the motion blur, bringing that up a bit, adaptive sampling to make it render faster. But also, let's add in a tiny bit of depth of field. Maybe not ridiculous, we'll see. So for this camera, I'm going to enable depth of field. We lower the, or not, we don't lower the distance. We lower the f-stop until it's like very, you know, blurry, and we can pick our focal point. So at what distance should we be focused? So you can see we can focus on these back ones or these ones in the foreground. Yeah, that looks super cool. And now we just bring up the f-stop until it's not as noticeable, but maybe a bit noticeable, because I like the look of it. Let's try re-rendering and seeing what we get. So now we have motion blur, depth of field, and soon we're going to have compositing. And yeah, that looks super sick. Again, you could go super intense with this depth of field, which might make it look a bit crazy, but maybe that's what you want, kind of like this macro effect. But it almost makes these feel like fish eggs. They're so tiny, so smooth. It looks good. Also, one more thing, if you're not liking that the facetting of these spheres, which you can barely tell, but if you care, again, the sphere right here is what we're instancing. So if we were to add like a subsurf, which will make it smoother, it's going to make all of these smoother at the cost of what? Of rendering a bit slower. So let's try rendering it. Shouldn't be a big deal, but it will definitely slow it down a little. But now you can see all these spheres are very ball-like, and when you see this thing in motion, which you've already seen, it's going to look much cooler because you can really see the motion and the size of it. So I think at this point, let's prepare to render this. And as you may or may not have known, this tutorial is sponsored by Concierge Render, which is a render farm for Blender. You can actually outsource your rendering to a place that will render it significantly faster than your computer, especially if you have a slow one. So let me show you how to set this up, how to render it there, and then we'll be done. So for this project, once you've done everything, we just got to prepare the blend. So first of all, we got to save. We've already done that, given it a name. But also, let's lighten up our blend file. So for cleanup, unused data blocks, get rid of those if you have any. Also, recursive unused data blocks. This will just get rid of any stuff that isn't actually used in the blend file. Second of all, go to external data, automatically pack resources. In this case, it doesn't matter. But if you have any textures, HDRIs that you need in your blend file, that's how you do it. Save it, and now I will meet you over at Concierge Render. Okay, so we're at conciergerender.com. If you do not have an account, just make one, and you will get $5 in free render credits, says it right here, which is actually a lot, especially if you have low sample counts and all this, but make an account, and let's log in. You can see my account has like $13, $14, should be plenty. So once you're inside, go to Upload and Launch Renders, because it needs to know what blend we're using. So I'm just going to go to Upload Files. What blend are we using? Well, I swear I've already forgotten the name. Playing with Points Patreon. There you go. You're just going to upload it. In this case, it should be pretty quick. We don't have any textures or anything. Find it in this list, and then you say Actions, Launch Render. It's going to think about it for a second, and then we can actually prepare our render. Okay, so here are the settings we need to pick through. I mean, most of them are obvious. So render platform, I did use 3.0 alpha, but everything we did should be compatible with 2.93, so I'm going to pick that. By the way, I have no idea what this is, but whatever. 2.93, render engine, cycles. So a lot of this will just look at your blend file and pick the right one. So cycles, render type, animation. We don't want an image, we want a bunch of frames. Frames and resolution, again, it's taking this directly from the blend file, so we had it set for like 250 frames. That's a lot. Let's have a couple seconds, let's say, I don't know, 180 frames at native resolution, which in this case is 1080p. And for the samples, again, took it from the blend file, but we could change them here. So I'm thinking it doesn't need to be much because it looked pretty good at 128. Let's do something like 250 samples. Hardware, this is what kind of matters the most. You want to pick, do you want a very fast hardware that will render super fast, but, more expensive, obviously, or slower stuff that's, whatever. Point is, pick something that's faster than the computer you're using. I'm just going to be using the basic stuff. Hit render. It's going to think about it, and then it's going to make a project for that. So you just go to the job manager. You go to the job, so I'm going to go to view details, and you can see here it's going to be chugging along, and by the end of this it's going to go all the way through the progress bar. It will tell you how long it took, how much it cost, etc. Okay, the render is now done. You can see all 200 frames are completed. You can see the start, the end time, and overall 200 frames. I bumped it up from 180. Cost $1.80, so under $2 for multiple seconds of high quality animation. And you could download all these or just go to download outputs, but just to check that it rendered what we said for it to render. Frame 1 looks like that. That is correct. And let's just make sure on a different frame it looks a bit different. It does, at least if memory serves correct. So Concierge Render, easy recommendation if you have a slow computer, or maybe you have a good computer, but your scene's super dense and it's big and you don't want to, you want to speed it up. Use a render farm, use Concierge Render. Thank you, boys, for sponsoring, and thanks everybody else for watching. That's it.